All right, we're back. We are on page 4 of note 16 of Calc AB. We are using the fundamental theorem to do things. And this is actually a similar type to a problem that we've already done before, where we're given like a couple of things. So we're given like a couple and then asked for something else. So I do these by drawing bars that represent things. So like, for example, I know -6. I need to go from -6 to 12, like total. So like I could draw one big number line that needs to go -6, and then 4 is on there, and then 12 is on there. And so I'm given -6 to 4. And then you want it to be, that didn't work at all. You want it to be like kind of representative. And then I'm also given -6 to 12. And so like looking at the picture we just drew, the most obvious thing they could ask for is what is 4 to 12. So 4 to 12 is definitely going to be -6 to 12. And then we're going to subtract -6 to 4. And if you draw these pictures, it can be really helpful. And now we just fill in the values, right? -6 to 12 is -3 minus -6 to 4 is 8. So -11. And I guess I should write that that'll equal 4 to 12 f of x dx. And then I'm going to duplicate that. Solved it. And then maybe we'll highlight it in some color. This is like my answer highlighter color, usually. I try to reserve it for that. All right, let's see what else we got. Assuming f of x is even, so they're like puzzles, and I love that. F of x is even, continuous function, such that the integral from 1 to 2 is 5. -2 to 1 is 8, and we want 0 to 1. All right, so I'm thinking, draw a number line that goes from -2 to 2, and put like 1 on it, I guess. So a number line that's going to go from -2 to 2, -2 to 2. I think I'm going to put -1 and 1 on it. And like maybe, and 0, because the question is about 0. Okay. All right. So it's continuous and it's even, and that's probably important. So we know 2 to 1, 1 to 2. Sorry, said that wrong. 1 to 2 we know is 5. So if we know that 1 to 2 is 5, because this is even, we also know -2 to -1 is 5, because the regions have to be the exact same size. So I'm also going to do that. I'm doing the exact same color because it represents that. Like this is 5 and this is 5. So we know both of those are 5. -2 to 1. All right, that's weird. -2 to 1 is 8. So this is 8. And we want 0 to 1. All right, I think I see the way through, because we now know, I need another color. Well, we know that this part from -1 to 1, if this is 8 and this is 5, then the difference must be 3. So this is 3. That's the only, because you need to be able to add this and this to get this. So that must be 3. Now, since this is the integral from -1 to 1 of f of x dx is equal to 3, but since this is an even function, that's 2 times the integral from 0 to 1, which means that the integral from 0 to 1 of f of x dx is 3/2, or 1.5. So that's a really neat problem. So we were able to do that because of the fact that it's even, and I think that the picture is really helpful. I mean, I don't know if other people find it as helpful as I do. I find that that's like the key to unlocking these. Like even sometimes the problems are like supposed to be more complicated than they end up once you draw the picture, and you're like, why wouldn't everyone draw the picture? I don't know the answer to that. All right, what do we got here? We have -2 to, I need to go from -2 to 8, basically, I guess. So -2 to 8, so -2, 0, 6, and 8. We're just trying to write this as a single definite integral. All right. So 0 to 8 is like given. Fine. -2 to 0 is also kind of given. So far so good. And then we're adding from 8 to 6, but that's actually, we want to subtract from 6 to 8. Like this is minus 6 to 8, f of x dx. So 6 to 8 would be here. So overall, the only thing that we're going to be left with, I don't know how to indicate this. I'll do it in whatever this is. All that we're left with is this, because we went from -2 all the way to 8, and then we subtracted from 6 to 8. So all we get, so to write it as one complete integral would be -2 to 6 of f of x dx. So I don't know, that one, that's that. What else we got here? Use the table of selected values. This is like, these whole notes just feel like review, because like everything kind of is reviewish. Use a table of selected values, differentiable, nice. So therefore also continuous. I don't know if it's relevant. To answer the questions, approximate from 5 to 16 using a left Riemann sum. Got it. All right, 5 to 16. So first we write the integral. Going from 5 to 16. Now we're not going to get the real value, so it's an approximation. And then it's a left Riemann sum. So first we'll go from 5 to 10, which is 5, and we'll use that -4. Then we go from 10 to 12, which is 2, and we use this, which is 3. Then we go from 12 to 16, which is 4, and we use this, which is 6. And that is -20, and 24 is 4, and 6 is 10. I believe that's correct. Okay, approximate f prime of 11. F prime of 11. So we use the secant line. We go to the left and the right. So we'll use this. Maybe I can like highlight or something. So we'll use this and therefore those. So we're going to go f of 12 minus f of 10 over 12 minus 10, which is 6 minus 3 is 3, 12 minus 10 is 2, 3/2. That's it. And then this is fundamental theorem, right? So this will be f of 16 minus f of 5. And we go to the table. We didn't use any of the primes the entire way through. Weird. I mean, I guess like weird. I don't know. So I need f of 16 and then f of 5. So it's 8 minus -4. 8 minus -4. 12. All right. That's the whole page. So that wasn't bad, I think. I don't know. I hope you didn't think it was bad. I'm going to end this here, come back in the next one, and keep going. So I will see you there.